So the homework we're about to do is going to feel hopefully a lot like what we did in part 1 of this video. I have your problem 1 up. I'm going to do problem 2. And in problem 2, the instructions want me to do some things by hand. Part A wants me to find the x-intercepts and the multiplicity of each. So for part 2A, to find x-intercepts, I set the function equal to 0. And set the factors equal to 0 to get the x-coordinates of my x-intercepts. So in 2A, it's already factored for me. I'll set the factor of x minus 5 equal to 0 and get x equal to 5. I'll set the factor of x plus 2 equal to 0 and get x equal to negative 2. In terms of an answer to what the x-intercepts are, the x-intercepts are going to be 5, 0, and it has a multiplicity of 2 because the exponent that created it was 2. And the important thing, more so than the 2, is that the exponent is even. The algebra that gave me a negative 2 gives me an x-intercept of negative 2, 0. I won't be able to write the whole word multiplicity. It has a multiplicity of 1 because that exponent has an implied exponent of 1. And again, the important thing is the sign of or whether the exponent is odd or even, not so much that it's the number 1. So that's the end of part A. Part B says determine if the graph crosses or touches the x-axis at each x-intercept. When the exponent is even, it touches. So at the point 5, 0, because it has an even exponent, the graph is going to touch the x-axis. Touches seems wrong there, but touch might have been better. And at the point negative 2, 0, because its exponent is odd, the graph is going to cross the x-axis. Part C and E I can kind of do in tandem. I can tell you the maximum number of turning points and the end behavior in kind of one big computation. So to do part C as well as part E, to get the maximum number of turning points and the end behavior, I'm going to write the problem without its exponents, and I'm going to multiply the first term in each parentheses. This is going to give me x times x times x, which is x cubed. For the maximum number of turning points, it's this exponent minus 1. So the maximum number of turning points is going to be 2. And I could also tell you the end behavior, that this graph, when I get far enough to the left or far enough to the right, is going to resemble the graph of f of x equals x cubed. That's all I can do with algebra. The rest of what I'm going to need to do is via my calculator. And specifically, I want to sketch a graph and approximate the turning points and label the x-intercepts. What I'm going to do is on my calculator, in my y1, I'm going to enter the function x minus 5 squared times x plus 2. And these functions are a nuisance to graph because the windows can vary wildly in terms of the y's. Since we're not doing calculus, it's kind of hard to know what the window should be. So for my x's on every graph that I do today, I think x min of negative 10, x max of 10 is going to be sufficient. If I don't have the graph in front of me, these graphs could have y's that are shockingly large. I usually start out with my y's really big, and if the maximum and the minimum are, well, let me show you. I usually start out with my y's really big, and then I make them smaller if I can. So I'm going to turn my y equals on. I'm going to enter the function parentheses x minus 5 squared times x plus 2, and hit my window button. I want negative 10 to 10 on all my x's, and for my y's, I'm going to do negative 100, negative 250 to 250. When I hit graph, if the maximum and minimum points are kind of towards the top of my screen, I'm going to leave that window. If the maximum and minimum points are way low on my screen, I'm probably going to crunch the y's down. So now I'm hitting graph. I don't know much about these resolutions, so I'm just going to hit enter. And when I hit my graph, that's okay. I probably like my maximum and minimums to be a little closer to the top of the screen. So just out of preference, I might make these lower now. Let me try maybe like negative 100 to positive 100. This is just because this is an adequate graph, but usually you try to set a window so that the maximum and minimum points are, kind of towards the top and the bottom of the graph if you can. And so now this is just guessing because we don't have calculus. That feels better to me. I could even crunch the window a little bit more if I want to. So right now on my graph, this point right there is the point negative 2, 0. The graph crosses the x-axis there. That point is the point 5, 0. The graph touches the x-axis. Eventually, I'm just going to transfer this graph onto a blank graph. And specifically, I'm going to make sure to get the x-intercepts proper. The x-intercept of 5, 0, and the graph touches the x-axis there. At the x-intercept of negative 2, 0, the graph crosses the x-axis. The other two points I need to put on this graph, well, actually there's just one more point I need to put on this graph because I have that minimum point already located. I need to get this point on my graph with 2 decimal worth of accuracy. So let's do that. How do I get that maximum point? To get that maximum point, I have the function graphed. Now I'm going to hit the second button, followed by the trace key to access the calculate menu. Now I'm going to press 3, or go down to option, actually I'm going to press 4 to go down the option that says maximum. So I did second and trace. Now option 4, I'm going to hit enter. I could have just typed the number 4. And when I do that, my calculator says left bound. What do I need to do when my calculator says left bound? I need to use my left and right arrows to place the cursor on the graph to the little left, a little to the left of the maximum point. So I'm going to use my cursor using the left arrow and get my cursor so it's blinking a little bit to the left of the maximum point, and then I'm going to hit enter. And when I hit enter, my calculator gives me this left bound indicator. It's a little arrow pointing towards the right. And on my new calculator, it makes a full line. Done with step 4, on to step 5. Now I need to set the right bound. See, my calculator says right bound on it now. How do I set the right bound? I use the same strategy. I use my left and right arrows to place the cursor on the graph to the little bit to the right of the location of my maximum point. So I'm a little bit to the right of the location of my maximum point, and then I'm going to hit enter. After I do this, my calculator says guess, and tell your calculator where to guess. How do you do this? Trace as close as you can to the desired point and hit enter a third time. So I'm tracing as close as I can to the desired point, hitting enter a third time. And now I'm going to round to 2 decimals. The x coordinate of that point I'm going to say is 0.33. The y coordinate of that point is 50.81. So I need to plot that point, 0.33, 50.81. Did that on my calculator already. So now all I'm going to do is sketch a graph. I'm going to label the x-intercepts and the maximum point and just connect the points the best I can. So I plot the point negative 2, 0, the point 0.33, 50.81, and the 0.50, and then just connect them with something that looks like something on my calculator. So make it kind of go up to the maximum point, come back down, doesn't have to be perfect, and then just have it look something like it looks on your calculator. Doesn't have to be perfect at all, just something that's reasonable. That's the end of part D. I sketched a graph, I approximated the maximum point, I labeled the x-intercepts, and the minimum point came for free. The last thing I need to do is state where the graph is increasing and decreasing. This is old school. To figure out where a graph is increasing and decreasing, we break the graph into panels based on the x's. This first panel goes from the far left edge of the x-axis, which has an x-coordinate of negative infinity, to the x-coordinate of the maximum point, which has 0.33, all around parentheses. The middle panel goes from the x-coordinate of the maximum point, 0.33, to the x-coordinate of the minimum point, 5. And the far right panel goes from the x-coordinate of the minimum point, 5, to the far right edge of the x-axis, which is infinity. This first region, the graph is increasing because if you trace along the graph, your marker is getting higher. The middle interval, the graph is decreasing, and in the far right interval, the graph is increasing. So if I want to write an answer to part F, symbolically, I'm just going to say it's increasing in the interval from negative infinity to 0.33, and then use the union, and then 5 to infinity. And it's decreasing in the interval 0.33 to 5. All around parentheses and increasing and decreasing. That's kind of everything in this section, but we just have to just amp it up. So there's your problem 3. Which is an evil problem, and because of the increasing and decreasing, there's a little trick to it. And problem 4. I'll do problem 4. And the increasing and decreasing, in a calculus class we need to be more precise than we might need to be here. But let's go through this. Here's the function. First find each x-intercept and its multiplicity. So for part A, to find the x-intercepts, I'm going to set the function equal to 0. I'm going to emphasize that x plus 1 has an implied exponent of 1. This I can do in my head. There's hardly any reason to show algebra here. Setting the function equal to 0. After I have it factored, I'd set the individual factors equal to 0. The x-coordinates of my x-intercept are positive 2 and negative 1. So my x-intercept is 2, 0, as well as negative 1, 0. The multiplicity of the 2, 0 is 3. More importantly, it's an odd number. The multiplicity of the negative 1, 0 is 1. More importantly, it's an odd number. So that's everything I need for part A. I've listed both x-intercepts and told their multiplicity. For part B, I need to determine whether the graph touches or crosses at the x-intercept. It crosses if the x-intercept has odd multiplicity. It touches if it has even multiplicity. So it's going to cross at both. Both have odd multiplicity. The graph is going to cross the x-axis at both. I could say it crosses at 2, 0. It crosses at negative 1, 0. That would be fine. Now, simultaneously, I'm going to do C and E. I'm going to find the maximum number of turning points and the end behavior. How I do that is I write the problem without any exponents, and then I multiply the first term in each parentheses. That gives me the function for the end behavior, and it gives me the exponent that I need to subtract 1 for to get the maximum number of turning points. And number 4, the maximum number of turning points is going to be 3. And the end behavior, this graph is going to resemble the graph of f of x equals x to the 4th if you get far enough to the left or far enough to the right. In terms of graphing, I'm going to plot negative 1, 0 on the x-axis positive 2, 0 on the x-axis. I'm going to graph this now, setting a huge window and then progressively getting it smaller till I can see something that's reasonable. So y equals, to find the turning points, clear this out. I'm going to do x minus 2 cubed times x plus 1. I always like my windows to start off at negative 10 to 10. And then if I have no idea what the graph looks like, I start with a really big set of y's. I hit graph. And boy, I can barely tell what's happening down there. The interesting thing of what's happening is really close to the x-axis, which means I'm way too zoomed out. I can zoom in to the hundreds. That's usually my second guess. Sketch a graph on the y's and see if I can tell better what's going on. I can tell better, but I probably could still, my minimum point so far from the edges of the screen, I like my minimums to be way closer to the edges of the screen, so I'm going to zoom in even more, maybe down to the 50s. This is completely non-scientific. It's just what I do without having calculus at my disposal. I don't know just what, oh, my y-axis is incrementing by 1, I think. I don't know what I just did there. Yeah, it is what it is. So even then I probably can go smaller because my minimum point's so far from the edge of the screen. Let me go even further, maybe down to the 20s. And there's not a right and a wrong window. I just have personal preference that I like my maximum and minimum points to be closer to the bottom of the screen. I could even go further down if I care to. I'm going to stop right now. The only point I need to find is this minimum point. To find the minimum point, I hit second and trace. Go down in this case to option 3. I could just type the number 3, or I could arrow down to 3 and hit minimum. Now I'm going to set the left bound. To do so, use my left and right arrows to place the cursor to a little to the left of the minimum point, and then hit enter. And when I do that, my calculator will indicate to me where it's going to start looking. Done with that step, move on to setting the right bound. To set the right bound, use, in this case, the right arrow to place the cursor on the graph a little to the right of the location where the minimum point is, and hit enter. And then my calculator, I need a guess. Tell your calculator to guess where the minimum is located. Trace as close as you can to the desired point and hit enter. And I'll round to 2 decimals. I'm going to say negative 0.25, negative 8.54. So rounding that to 2 decimals, negative 0.25, negative 8.54 is my minimum point. I plotted, now on my graph, I plotted the x-intercept of negative 1, 0. I plotted the minimum point rounded to 2 decimals. I plotted the other x-intercept, and I just connect them with something that looks like my calculator. I can't graph very well by hand, so I cheated and had the graphs pre-set up so they would look better. But if your graph doesn't have to be this nice. So done with that. Now just for increasing and decreasing, if we wanted to, we could just make this graph into 2 panels. We could say it goes from negative infinity to negative 0.25, and then negative 0.25 to infinity, because there isn't another turning point. This evil point here, the graph actually gets completely flat there, and it actually stops increasing for a second. It increases, goes flat, and then increases again. It would be more correct to do this, to split this into 3 panels. Even though that's not a minimum or a maximum point, it's still kind of a, I don't know if we call that a saddle point, I forget what it's called. But this would be a more appropriate way to break the graph up. But if you just had the one interval from negative 0.25 to infinity, that would be okay too. But the best correct answer would say this is increasing in this interval, the negative 0.25 to 2. It flattens out, doesn't decrease, and then it starts increasing again from 2 to infinity. It would be completely okay, and I wouldn't put this on a test anyways. If you brought 0.25 to positive infinity for the increasing there, that would be fine. because looks like it's completely increasing, and that flatness it's not that big of a deal in an algebra class. And the decreasing part is negative infinity to negative 0.25. Let's do 5 together just to knock out one of your homework problems. So 5 wants me to start off, list the x-intercepts and their multiplicities, gives me a nice factored function. So for part A, I'll take the function x plus 3 times x minus 3 times 3x plus 21, set it equal to 0, emphasizing because the exponents weren't written, they're implied ones. This guy, if I set it equal to 0, would give me x equal to negative 3, which would give me an x-intercept of negative 3, 0. The multiplicity is 1, which is odd. That guy, if I set x minus 3 equal to 0, I'd get x equal to 3, would give me an x-intercept of 3, 0. Multiplicity of 1, which is odd. This guy, maybe you need to do the algebra to get the x-intercept from it. If you set the 3x plus 21 equal to 0, you'd minus 21 from both sides and get 3x equals to minus 21. Divide by 3, divide by 3, you'd get x equal to negative 7. That would give me an x-intercept of negative 7, 0, multiplicity 1, which is odd. Done with part A. For part B, determine whether the graph crosses or touches. Each of the x-intercepts has an odd exponent. It's going to cross at each. So I usually, if it does the same thing on all the x-intercepts, I usually don't separate. I just generically say this will cross the x-axis at each x-intercept, rather than saying it crosses at negative 3, 0, it crosses at positive 3, 0, it crosses at negative 7, 0. I usually wouldn't say that. I just generically, like that would be fine. Now I'm going to do C and E simultaneously by multiplying the x in this parentheses, the x in that parentheses, and the 3x in that parentheses. That's going to give me 3x cubed. That's what the graph is going to look like if I get far enough to the left or far enough to the right. For the maximum number of turning points, it's going to be that exponent minus 1, so it's a maximum of 2 turning points. So now I need to get to the part where I sketch a graph and I label the maximum and minimum point on the graph. I know I'm going to plot the x-intercepts. The graph is going to cross the x-axis at each x-intercept. And now I'm going to put this in my y1. I'm going to find that point and that point. Start off y equals, clear, put in x plus 3 times x minus 3 times 3x plus 21. Set my window up. Usually I make my y's giant. 200s, 250s, it doesn't matter, just big. The x's usually can stay at negative 10 to 10. When I hit my graph button, that almost looks good. Well, it's actually not even good enough for me because that y isn't low enough. That y is so low on the screen that I might not be able to find it, which means maybe I should have set my window to the 250s. Completely unscientific. I just pick y's that are big and adjust them to get the maximum and minimum points kind of okay located in the window. Now I need to find that point and that point. This point is the maximum point. To find it, I hit the second trace calc key, go down to option 4 that says maximum, hit enter, use my left arrow to get the cursor to the left, a little to the left of the maximum point, and then I hit enter. Then I trace, so I get my cursor a little to the right of the maximum point and hit enter, and then I get as close as I can to the maximum point and hit enter. Round to 2 decimals, negative 5.24 and 97.46 are the coordinates of that point. And then for the next one, second calc, go down to the minimum option, trace and get your flashing cursor a little to the left of the minimum point and hit enter. And then trace and get your cursor a little to the right of the endpoint and then hit enter. And then trace and get your cursor as close as you can to the low point and hit enter. And for this, I'm going to write 0.57, negative 197.01, which I did down here. And now I plotted these points. I plotted the 3 intercepts. I plotted the maximum point, plotted the minimum point, and then just connect them with something that looks like the graph that's provided. To find where the last part, where the increasing and decreasing part is, I break the graph into the regions. The first region is going to be negative infinity to negative 5.24 x coordinates, and the middle region is going to be negative 5.24 to 0.57. The far region is going to be 0.57 to infinity. When I go to answer part F for the increasing, it's the outside intervals. This graph is increasing in the interval negative infinity to negative 5.24 and in the interval 0.57 to infinity. Put a union symbol between those. And it's decreasing in the interval negative 5.24 comma 0.57. Let's do a graph where the x-intercept isn't obvious. I'm going to skip a few because I think these get repetitive. And I'm going to finish up. We'll do 2 more problems of this type. I'll do problem 10, which will match up with your problem 9. And I'm skipping some problems because I think I have too many here. And then I'll do problem 14, which will match up with your problem 13. What these problems have a little bit different is that I have to do a little more work to find the x-intercepts. So I'm going to pause and start at part 3, do these 2 problems, and then buried at the end of the section, there's one other kind of problem. I'm not going to get to do every single graph, but I don't think I need to do every single graph. I think at some point they're just repetitive.